Welcome to Filtration Matters, a regular podcast from BOFA, a world leader in portable fume and dust extraction. In this series, we'll be exploring how innovations in filtration and extraction system design are helping improve productivity across multiple industry sectors, including in laser, 3D printing, and electronics. BOFA experts will discuss how advances in extraction technology are helping optimize manufacturing processes and product quality, while at the same time contributing to a clean, healthy working environment. Today we're looking at additive manufacturing as investment in 3D printing grows around the world to take advantage of increasingly sophisticated technology. It's transforming the manufacturing landscape across multiple sectors and helping to address some of the supply chain challenges that have emerged in recent years. As this expansion continues apace, the focus is increasingly turning to optimizing the value of the performance qualities being made available through materials science. However, with these new generation materials comes the need to ensure that the filtration of human particles keeps pace to help operators maintain uptime and to protect operatives from potentially harmful emissions. To help us navigate our way through this evolving environment, we're joined by Technical Development Manager Nigel Bedford, who is part of the BOFA team involved in ensuring that the company's fume extraction systems meet the needs of operators and their people. Welcome, Nigel.
Hello, Phil. Great, thank you. Thanks for having me. Looking forward to it.
Thanks, Nigel. Perhaps you can start by telling us something about your career to date and your role at BOFA.
Yes. So we'll keep it short. I've had a great career, lots of opportunities. So 10 years in automotive R&D, followed by nearly 20 years in aerospace, manufacture, repair and overhaul for big tier one OEMs. And then just before BOFA, a couple of years with a very small repair and overhaul facility in Dublin. Been with BOFA for a year, a little bit of work with the R&D team, and then the last 6 months really heading into additive manufacturing, filtration, and a whole new world. So it's good fun and enjoying it.
Thanks, Nigel. So let's create a little context here around the evolution of 3D printing, particularly in terms of the expansion of additive manufacturing around the world. What have been the main drivers for this growth, do you think?
Yeah, so there's no question that the supply chain difficulties have really helped this industry to develop. Aerospace and low volume manufacture, I think, will be really beneficial from it. Probably a little way away from the real big volume stuff, if ever, frankly, but certainly helping to fill those supply chain gaps would be really beneficial, and also from a design point of view. So as designs are evolving and new machinery is evolving, the ability to build more complex things, shapes, is a real plus for additive, and also the ability to get several parts manufactured in one assembly rather than sub-assemblies, which you then have to connect and bolt together, or however that may be, is bringing some real benefits. We're seeing that all over the place.
And I guess that this growth is perhaps most illustrated by the number of machines, for example, that companies might be investing in, whereas historically it might have been one or two in a particular shop. Now, are you seeing sort of growth in the numbers of 3D printers that are being invested in perhaps in a single location?
Yeah, so people are starting to talk about that. I haven't seen too much evidence of that personally, but I'm sure they do exist. But there's a lot of talk of print farms, 50 machines, 100 machines, really doing the volume stuff. And that's where all the challenges for the whole infrastructure, including filtration, I'll be selfish for a minute, comes in. That's a whole different world to the ones and twos machine territory. We'll see how that develops, but that is definitely the path that machine manufacturers are looking at. Is they're calling them print farms. Dozens of machines looking forward, and that's also driving some of the sizes of machines. We know some AM machine manufacturers have been very torn between the very low volume big parts or actually going for multiples of very small parts. So maybe a 250 millimeter cubed print area, and lots of them, as opposed to a 1 meter cube print area. There's a market for both, but there's certainly some division there around which way companies should head.
And do you think there's a role for 3D printing in what we might think of traditional manufacturing processes like tooling and molding? Is there a role there for 3D printing?
So today, undoubtedly, for very low volume and particularly for tooling, it's very useful to be able to quickly knock out a first off and then maybe modify, amend. Certainly, as machines get faster, there's no reason that volumes couldn't increase. We're seeing machines now. There was an alert on one of the websites a few weeks ago that machine now out there with 26 lasers. So that's going to really have some production capacity within one asset. So see it going that way. But today, I would still say it's low volume, maybe a dozen offs is where it's really very beneficial.
I guess the growth in interest in 3D printing seemed to be accompanied by the development of new generation materials for this market. What sort of materials have you seen emerging and why are they being adopted?
Yeah, so interesting topic and one we're really getting our arms around. And, we're having conversations with some machine manufacturers who are getting into super alloys, particularly for aerospace and defence and space applications that are very reactive, and they're looking for solutions early on around how to manage those. But then there's the other side, PEEK, for instance. So very good material in terms of tensile strength, flexural strength, particularly for a polymer, not a metal. Very good wear and abrasion, and used a lot in medical for joints and the like. But actually, in some applications, we're seeing that as a replacement for stainless steel in the right application. Tungsten's starting to really feature. Previously very hard to print due to a very high melting point, which in itself makes it good for some applications, but excellent at resisting heat and wear. Again, very good for tooling manufacture because it is so tough. And again, that's very low volume stuff. Interestingly, once 3D printed, it has very good characteristics for shielding radiation. So again, good for radioactive processes and protection of personnel in those environments. So seeing that one come through more and more.
So these sound like very exciting innovations, but what does it mean in terms of filtering out any potentially harmful airborne emissions?
Yeah, so there's a couple of paths here really. This is where it gets interesting for us. So for the metal printing side, we're not so concerned about filtering out the harmful emissions. What we're trying to do there is keep the print chamber clean. So protecting the laser, stopping deformation of the laser onto the print area and the manufacturing process. And then for the plastics and the non-metallic, we are really there about people's safety and health. And my son's recently bought a new printer, a very fast, very high power laser, but the smell in the house is remarkable compared to his old printer. It's been quite a switch on for me to walk in through the front door and think, oh, Dan's printing. The house never used to smell like that. So he's actually got a BOFA 3D Print Pro unit, which I thought was probably a good investment a few weeks ago. And that really is from a great bit of work the team here have done with a firm called Combustion. So what we're doing there is looking at the filtration efficiency of the carbon and HEPA filters, which BOFA manufacture, and looking at how they remove the not only the particle but also the noxious smells. It found to reduce those VOCs by 99.8%. So the mantra for the testing was ABS and PLA at 200 and 250 degrees C nozzle temperature, and the machine on and off, and also actually the enclosure door open and closed. And some people think the door in itself is enough. This report demonstrates it really isn't. It does contain that, but not once you open the door, it all escapes, and you get very high levels of VOCs in the room. So that combustion report is going to make its way into white paper and release that shortly. But very interesting results. We see a step change in the VOC particulates into the room within only a few seconds, and it's it really is quite a remarkable difference very quickly.
Okay, so we look forward to the white papers. Definitely, it sounds really interesting. But I guess the other aspect that needs to be considered beyond atmosphere management is the impact that these emissions can have on product quality and uptime if they're not, if emissions aren't properly controlled. I mean, that's, for what you were saying earlier, that's also a focus for BOFA.
Yeah, absolutely. So, we live in a commercial world, one of safety first, commercials close second, and keeping these machines online is certainly a big focus, as well as the skill level required to operate the machines and keep them maintained. And then, of course, the cost of waste, which is getting more and more impactful on operations. These areas actually are what will limit the growth of the AM print farms that we're talking about. So managing one or two machines very manually is okay. You start to talk about 100, and that's a whole different level of operation. So we've got the commercial piece for sure.
So what's the potential impact of not controlling the emissions properly in terms of product quality? I think you may have mentioned this a little bit earlier. And what effect can that have on the actual process then?
So if we flip over to metal printers particularly, they need to operate in an inert environment. So typically argon, but possibly a nitrogen rich environment. So the filtration needs to be really well sealed to maintain that. Otherwise, we start to see oxidization of the print as it's being produced. We can't have downtime, so the filters have to last a long time. They need to see through the whole print cycle. Stopping that print to change a filter would leave a flaw in the material in the model being built, and of course we'd have to then control that in an environment again. And finally, we're getting some reactive materials here. So we're talking titaniums and aluminiums at a very, very small particulate size down to submicron level, which is generated in the smoke that's produced by the laser. We need to be careful about exothermic reactions when we come to remove that filter, and it gets exposed to oxygen. So that's part of the bigger program that we're working on, is how we manage to safely change filters, safely react filters, safely dispose of filters, and looking at maximum machine uptime. So a productivity thing, yes, but also a fundamental requirement of these machines to keep going for the full print cycle, print time.
So that sort of brings us neatly on to how BOFA ensures that its technology keeps pace with the materials and the processes that are being used. So what's BOFA's approach to that, to sort of staying up to date, if you like, with processes and materials?
So we've got a good team here on site in Poole. Of course, we're part of the wider Donaldson group now. So a lot of talent. So keeping a foot of technology is kind of my job and where we're heading. So we've partnered with a few good OEMs and a few technology centres and universities. Meeting a few more of those this week. We have a couple of chemists on site who are very, 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 very switched on to materials and how they react and how we should be treating those. And interesting call a couple of weeks ago actually with our chemists in Thailand from the Donaldson facility, who are actually responsible for disk drives, but very interested in anything chemistry. And we were talking to them about passivation and good ways to control that reaction. So mixed team, industry contacts. These podcasts are great. We're at Form Next in the next couple of weeks, so we'll have a really good look around there and lots of deep and meaningful conversations, I'm sure, on our stand. And it's all keeping us well informed and learning all the time, actually, as I think a lot of the industry is.
So for people who don't know too much about the BOFA filtration system, perhaps just explain what a typical filtration system looks like for additive manufacturing. And I think maybe reference even something like the AM400, which I think helps to address one of the issues that you mentioned in a previous answer. So can you tell us a bit more about that?
Yeah, so we've got a machine out to market already called as you rightly say, Phil, the AM400. So that incorporates a blower and control and a filter device, which is pretty easy to move around. That's especially important if we want to get that to a station for passivation. It can be locked off and sealed and taken somewhere to be reacted. Mm-hmm. Good device. Some people see some really long print times, particularly if they've got low gas flows and a small print chamber. Commercially available, it's out there now.
Thanks, Nigel. So what's the direction of travel for filtration more generally for additive manufacturing, do you think?
Yeah, so certainly heading towards more automation. If we think of the print farm, 50 or 100 machines in a room, that's going to take a lot of labour to manage filter changes, maintenance, all that good stuff. So we need to be thinking about that. So long uptimes, simplicity, being able to easily clean any devices, and also change between different materials. We're aware that some machines are going to be swapping between when we really can't mix those materials. And say long uptime, I think, are the keys going forward.
And it sounds like there's some development underway at BOFA to answer these challenges. I know you can't say too much yet, but you give us a hint just to say that actually, the work is in progress, as it were.
Yes, yeah, we're on a path. We have some designs in work, and so far feedback from key partners is pretty positive.
Excellent. So just looking ahead, how do you see the additive manufacturing industry developing over, say, the next 5 years when it comes to the wider adoption of the technology and perhaps the role of filtration? How's that going? What might that look like in a few years' time, do you think?
So I think we're definitely heading down two paths. There's the really large scale big printers, the 1 meter cubed, off maybe into government institutes or off into the aerospace sectors, real specialist stuff. And then there's the other end. There's the 250 millimeters cubed, print chambers, much lower flows, but equally demanding. But a lot of those, I think there's some heartache in some OEMs around which way to go. So I think the print farms will be a thing going forward. I think there's a lot more required in terms of development of processes to enable that. I think it's even so much machines, I think it's processes. So I think the technology is through that exciting new phase, and people are now really looking at the true benefits, the cost benefits, the productivity benefits. And that will now come through in terms of genuine, mature reasons for adoption of the technology rather than through the fad stage. So that's what the next 5 years holds, is much larger machines, a lot of very small machines, and some genuine business case approval for why the technology should be adopted.
Many thanks, Nigel, for your expert insight into the fascinating world of material science and what this means in terms of product performance and expansion of additive manufacturing. We look forward to hearing more about BOFA's innovations in this area in the months to come. Thanks very much. Thanks,
Phil. It's been a pleasure.
If you want to find out more about BOFA and the benefits of filtration and fume extraction, visit bofainternational.com, where you'll find lots of sector-specific information. You can also catch up on all our podcast content by visiting bofainternational.com/podcast.